Hello, I'm Ashley Rice.
And I'm Melinda Rose, and this is Light Matters for April 17th, 2013.
On this week's show, the Navy will have a shipborne laser cannon in 2014, injectable LEDs and a transparency-inducing hydrogel aims to aid brain studies. An all-optical circuit is made from irregular diamond, and we chat with a committee member of the Tech Transfer Program of CLEO 2013.
Navy leaders recently announced plans to deploy a solid-state laser aboard a ship for the first time in fiscal 2014. The laser weapon system will be deployed aboard the USS Ponce, which patrols the Persian Gulf. The deployment, 2 years ahead of schedule, was made possible through significant progress by Navy researchers on directed energy weapons. The at-sea demonstration in 2014 is part of a broader Navy portfolio of directed energy programs, which are becoming increasingly attractive because of their low cost. Each laser shot costs less than $1, while firing one missile costs hundreds of thousands of dollars. The Navy previously showed it could disable a small target vessel by setting it on fire using a different solid-state high-energy laser mounted onto the deck of the former USS Paul Foster. We brought you that story 2 years ago this month on Light Matters. Last summer, the laser weapon system was put aboard the guided missile destroyer USS Dewey in San Diego and used against a drone aircraft. While lasers have benefits, they also have significant drawbacks, which include the fact that the beam can be scattered by smoke, water vapor, and dust, and that, as a line-of-sight weapon, it requires a visible target. Following the USS Ponce demonstration, the Navy and Department of Defense will continue to research ways to integrate affordable laser weapons into the fleet.
Optogenetics is big news these days. Last week we told you about Obama's brain initiative, and this week we have two stories about using gene therapies that cause light sensitivity in specific areas of the brain. Here's John Rogers at the University of Illinois talking about the practical challenges and benefits of optogenetics and how his new micro-LED research works.
Strategic implementations of these optogenetic ideas allow one to tease out the behavior of the brain, especially conducted with these kinds of technologies that can lead to insights into Alzheimer's disease, Parkinson's disease. For an application like optogenetics or other investigations of the brain, you'd like to be able to deliver that electronics down into the depth of the brain. And the question is, how do you do that? This entire system mounts on a miniaturized needle device with a dissolvable biocompatible adhesive. So you can use the needle to inject these devices down into the brain. The adhesive dissolves away and you simply remove the needle, leaving behind classes of very advanced optoelectronic systems that have cellular scale dimensions.
Although the current research is limited to mice, there's clearly a long-term potential for direct impact on human health, Rogers said. The work appears in Science.
In other optogenetics news, Carl Diceroth of Stanford has used a hydrogel to render a brain transparent to light. Here's Diceroth explaining the Clarity project.
What Clarity provides is a way of not having to disassemble the tissue, and so that addresses the challenge of the reassembly and reconstruction process, both the practicality aspect and the scientific aspect. So, for example, one can take an entire organ, like a brain, and make it completely transparent to light. It's a way, really, of transforming a complex biological system into a very accessible and informative new state. Having the confidence of three-dimensional knowledge of how tissues are constructed is important for development. It's important for disease research like cancer, where one would like to know the spatial arrangements in volumes of cancer stem cells, the niche or the location where cancers develop. And so we anticipate that Clarity may be useful across fields of biology, and both in normal and disease states.
The work, performed primarily on a mouse brain but also used to image zebrafish brains and preserved human brain samples, was described in Nature.
Circuits made from a not-so-pure form of diamond create new possibilities for all optical sensors. Diamond is optically transparent over a wide range of wavelengths, including the visible spectrum, making it attractive for use in optomechanical circuits for sensors, fluorescence imaging, or for novel optical biological measuring methods. Until recently, such circuits were made using highly purified monocrystalline diamond substrates. Because of their extreme purity, these circuits are tiny and require sophisticated fabrication. Now, for the first time, researchers at KIT in Germany used more irregular, robust polycrystalline diamond to fabricate wafer-based optomechanical circuits. Although less sophisticated, polycrystalline diamond conducts photons almost as efficiently as the monocrystalline substrate and is suitable for industrial use. Results were published in Nature Communications.
CLEO 2013, taking place in San Jose in June, will once again feature a technology transfer program. I spoke earlier today with Program Committee member Amy Phillips of the University of Arizona about what we can expect to see in this year's forum.
This is the fourth year of the technology transfer program at CLEO, and it is designed to provide a forum for discussing emerging technologies that are license ready but perhaps need a bit more commercialization, or perhaps they are all ready to be already prepared for being adopted by an existing company. We talk about startups, funding of new companies, licensing issues, all of these things. So we're now in our fourth year, and the program this year will take place on June 13th. It is free to anybody who has the registration type of the free Exhibit Pass Plus registration. And also there will be a webinar this year on May 23rd in preparation for it. And there will be more information about that on the CLEO website.
And why don't you tell us a little bit about who's speaking this year?
Yes, the technology transfer program content does include speakers. The first part will be a tutorial where we have somebody from a university as well as somebody who's founded a company, both of them talking about different ways to manage the valley of death. And then we'll have 5 speakers who will actually showcase their technologies. Again, someone from a university and then several people from companies with license-ready products. And then to finish the set of speakers, our keynote speaker is Dr. Robert Norwood, who is a professor at the College of Optical Sciences at the University of Arizona. And he's going to be talking about significant personal decisions that have to be made when you are entering into a startup company.
The program takes place on Thursday, June 13th in the exhibit hall session area from 9:30 to 12:30. I'll be there, so stop by and introduce yourself if you're there as well.
It must be exciting seeing all those great ideas that could become real products in a few years.
Yes, you definitely find yourself rooting for some of these technologies to make it across the so-called Valley of Death.
That's it for this edition of Light Matters, Photonics Media's weekly newscast.
As always, you can write to us with your questions or comments at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.
Nature, all atoms and things emit their own special kind of light. And so I'm very interested in looking at the spectrum of light in order to figure out what happens in nature. But specifically right now, individual nuclear reactions put out their own color light. And so I'm trying to figure out what nuclear reactions occur in some of the cold fusion areas.